a lot of the work that goes into making Formula One so exciting happens away from the track. And so a lot of the work of developing the car and all that is done by hundreds of engineers using large-scale computing. And true with Formula One trying to come up with the rules. So there's the on-track stuff. AWS is helping through these F1 insights, those sort of graphics you get that come up.
Yeah.
Say, hey, this person's more likely to do a pit stop than another, or we think this person could overtake this, or we use machine learning and SageMaker to do that. But people are maybe not as aware of all the work behind the scenes to do the complex maths to actually, power some of these solutions.
Computational Fluid Dynamics, CDC, or high performance compute, HPC, are probably not the two words you would hear quite often in your life, unless you work in the F1 industry, which is an aerodynamic industry, whereas with planes and otherwise, you probably would have heard HPC, high performance compute, thanks to all the generative AI conversation on. Yes, Chat GPT and others like Chat GPT use HPC in the background. So if you are someone who's really interested in just understanding how do people model a F1 car as the best aerodynamically possible design car in a way that can go fast as possible while keeping the driver safe. But this was really for me to understand that, hey, before cloud was the thing, how were they doing aerodynamic? And Neil was able to share a lot about how it should be a case because he used to work for F1 before. He did AWS, and that was really interesting for me personally. And I think the way these things continue to evolve more fascinating for me as well. So in this episode, you get to hear from Neil about how F1 is changing using cloud so that they can go faster while keeping the driver safe. If you enjoy this, definitely hit the like button so we know that you enjoy content like this and we should bring more of it. Otherwise, enjoy the episode with Neil Ashton, and I'll see you in the next one. Peace.
Cool. Actually, maybe a good place to start would be, Neil. For people who don't know who you are, what got you into the space, man? Like this HPC, CDF, or CFD. I can't even say the acronym right. But so tell us a bit about yourself.
Yeah, so I guess I've always really been like an engineer/geek at heart.
Yeah.
Really loved space and Formula One and things like that. So I always had a passion for trying to get into that area and help it. So I started life actually. First job was working in Formula One, helping to the aerodynamics. So, like the airflow around the car. And that involves a lot of compute and a lot of maths and physics.
Yeah.
And really from there, I kind of got into trying to do that as broad as I could. So I worked for some time at NASA, doing it more on like the aerospace side. But I always had a passion for the compute side and the like numerical methods and that sort of thing.
Yeah.
And I saw how much the cloud had a possibility to be a big disruptor in this space. And so, I joined about 3.5 years ago to AWS as the sort of subject matter expert for CFD, which maybe we can get into.
Of course. A bit. But HPC is another acronym that, it's funny, I used to think security is the only field with a lot of acronyms, but now I feel like, wait, there are more fields which have a lot of acronyms. So What is HPC and what is CFG?
Yeah, sure. Okay, so the way I would describe it is this. If you were to try and design a Formula One car right now, you could try and do it physically, like as in you could drive the car around and then make some change on the shape of the car to help the airflow go over a bit better and maybe make it faster or use less fuel or something. But that would be very much trial and error to try and change it, build another car, try to gate it.
Expensive as well, I imagine.
Exactly.
Yeah.
So what's become, and increasingly become the norm, is to try and use computers to it, actually pieces of software that actually do some really complicated maths in the background, solve all these equations, and actually on a computer screen show you the airflow over a car. Now that is called Computational Fluid Dynamics. So fluid dynamics using computers, so CFD. But as you can imagine, because there's a computer in the front of it, you need lots of computers. And so if you were to try and do, let's say, one of the CFD simulations of a Formula One car on your desktop, it would take years. In fact, it probably would never run, it would take years. So you need to have a supercomputer or high performance computing, HPC, to do it in a practical time, let's say a few hours. So, yeah.
Interesting. So I guess that kind of is one benefit of from an F1 perspective. Are there other industries as well that can utilize this same capability? I mean, maybe not from an airflow perspective, but fluid dynamics feels like there may be other industries that can benefit from it as well.
Yeah, absolutely. So, I mean, on the Formula One side, this is one of the core things we did with Formula One and AWS. This was one of the core parts of our partnership, was to help them to do this CFD faster.
Yeah.
So they basically, before it took like 60 hours to do one of these simulations. And then when they moved to us, it took like 12 hours.
Oh, wow.
So the way I always give an example is if you come into the office, and you sit down and you're drawing this car and you press go, I mean, I'm simplifying it, but if you press go, and you have to wait 60 hours, what's that, like a few days?
Yeah.
So you're waiting a few days to know if the answer's right or wrong, or better or worse. Whereas if you can do it in 10 or 12 hours, they work long hours usually.
Yeah.
So you can come in the morning, press go, by the end of the day, you got your answer. So that's a sort of meaningful impact. But yeah, to answer your question, in terms of other areas, absolutely. I mean, anything where there's air, water, blood flow, anything is an application potentially of, computational fluid dynamics. So like one of the cool projects, and I get excited about working with this because, as I said, it was a passion to work on these topics, is like we work with this company, Joby Aviation, who are building these eVTOLs, electric, vertical takeoff and landing, which is basically a flying car.
Right.
Like,
I was going to say, like that sci-fi movie. Yeah, okay.
And it's really exciting because that genuinely has the promise of solving a lot of the inner city urban transport issues. Let's say getting from London, Gatwick into the city centre of London, or New York airport into New York more efficiently. So they use CFD, and they were running on AWS to study the airflow over these drones and also the noise of these drones and how they can minimize it, things like that. So,
what role is HPC playing in all this? What is it as well?
So HPC is just, okay, the way example is you've got a computer and everybody knows any software. Let's say you're doing video rendering.
Yeah.
You've got how long does it take to render? If you have a bigger computer or more powerful, it might render faster.
That's right, yeah.
But when it comes to something like CFD, there's a limit to how big one computer could get, if you know what I mean. So when we say supercomputing or HPC, what we really mean is a collection of lots of computers all working together and essentially splitting the problem up. And HPC actually is something that is used well beyond just CFD.
Yeah.
So CFD is a classic example where you say Formula 1 car, instead of taking 60 hours, could take 12 hours. But it's also, if you're ARM and you're developing semiconductors, chip design, you need to do many, many simulations for that. Or if you're a bank doing trading and you're looking at different scenarios or you're doing Monte Carlo analysis, you need lots of computers to do it.
That's right, yeah.
Or chemistry, or almost any weather modeling is a classic one. So really anything where you need a lot of compute is an example of where HPC could come in.
Right, and because I think there's a lot of usage, or at least the terminology HPC keeps coming up with the whole generative AI as well. So there's that.
Exactly. I mean, this is at our reInvent conference. Peter DeSantis, who's one of our leaders, was talking about some of the hardware kind of innovations we've done. But the truth is, HPC is literally the core component for machine learning. Because if you want to train one of these massive Gen AI models, foundational models, you need to run potentially on thousands of GPUs all working together. That's exactly the same in terms of like infrastructure that you need to run a CFD simulation. So this is this really interesting convergence between HPC, and that's what's made any of these Gen AI models possible. If you didn't have that much compute in a supercomputing like manner, it wouldn't be possible.
So what's required to run something like this? So I imagine a lot of companies out there, and maybe who are thinking about this fluid dynamics space as well. Where does even one start? Like, I think even to your point, someone on the other end is passionate about working in F1. They hear about CFD, HPC, and I love those acronyms. I want to work in that acronym, whatever that acronym space is. Where does one even start in like, hey, what's the use case? What are people trying to learn? Sounds like there's a bit more to it, the engineering part. What's the computer side of it as well?
Yeah. Well, I mean, it's a fantastic space to get into. If any of your listeners, readers are interested in cloud technology, interested in the tech sector, high performance computing and scientific computing is a hugely growing area. With machine learning now, there's so much need for people who are genuine experts in the underlying like numerics, but also how they would use AWS, how they would use the services that we have like EC2 or SageMaker or Parallel Cluster and bring them together in a full API driven workflow. Also, of course, all the guardrails and security side around that. So it's a really booming area because, like I said, the traditional way of just having one server and just clicking, or can I get a larger instance of that server, that breaks down at some point. You need to know how to bring them together in a cluster. And that's where it gets more technical and you need more of the kind of specific knowledge around that area.
And what are some of the challenges you feel that are there in the space at the moment? Maybe technical and non-technical that people are talking about.
So one of the key ones is how you would schedule the jobs. So if you think about it, you could say, I want to run 100 instances on AWS of something. But if you were to manually do that and manually type AWS EC2 run instances or whatever the command you're going to do or do it in the console, that's not a very efficient way of doing it. What if you need to run 1,000 jobs? How would you schedule that? How would you orchestrate it so that they run one after each other? Or maybe they all try and run at the same time. So this is where there's AWS services like Parallel Cluster cluster or AWS batch that try to take some of this hard work away from you. But that's certainly some of the challenges or things that people can help other companies to do. If your listeners looking for new areas to grow into, new things to learn, I'd say that's a key area to understand the technical aspects of high performance computing.
What about from a leadership perspective? Because I think we were having a conversation where a lot of people are looking at making their own language model, and I think Amazon has come up with their own compute system as well that you can use to build your own LLM if you want to as well.
Yeah.
From a leadership perspective as well, what are some of the challenges? I mean, I guess a skill set is probably an obvious one. Are there anything else that you see as that would be a challenge in this space for companies who are looking to get usage of HPC in their environment for whatever reason?
Yeah, I'd say that the HPC can be something that can give them an advantage to get faster to market and being smart about how they're doing it. One is obviously there's a lot of work on in terms of Gen AI, the models, and things like Bedrock give you access to a range of models that you could fine tune or whatever. But if you want to also be trying to develop your own things, then you also need the capability to do large scale training, large scale inference. And so I guess from a leadership point of view, you need to build up that knowledge within your company of all those kind of levers that can give you an advantage over another company because you can do it faster or at a lower cost. We've got things like Trainium and Inferentia that are chips. And if you can take advantage of those, you might be able to create your model, or it's the CFD model or machine learning model, faster than your competition can. To summarize it, I guess it's being aware of this space between ML and HPC that is actually very close. And perhaps more people maybe know about the ML side than the HPC side. Whereas actually knowing about this side can make a big difference.
Especially engineers, I imagine they would have to work quite closely with HPC rather than the LLM part, because that's more data scientists and stuff.
Yeah, and certainly from the equivalents on Formula One, and this is kind of where we helped them, was they had the very deep knowledge of Formula One aerodynamics and also CFD, but they maybe didn't have the deep understanding of how to use HPC and AWS to achieve that goal. And that's where the partnership came in to try and say, we'll partner with you to give you the best possible stuff to train you and educate you so that you can do the bit that you know faster and better.
Awesome. Well, I guess, is there maybe a fun final question then? Is there something that people have asked you about the space that I haven't asked yet? Because we were definitely curious because it's the F1 space and not many people outside of the fact that, hey, there's an F1 race and people follow and Lewis Hamilton. But you're almost like, is there anything that people normally ask in the space from a technology perspective that we haven't asked yet?
Yeah, no, I think you've done a great job with the questions. I guess the parting thing is just a lot of the work that goes into making Formula One so exciting happens away from the track. And so a lot of the work of developing the car and all that is done by hundreds of engineers using large scale computing, and true with Formula One trying to come up with the rules. So there's the on track stuff. AWS is helping through these F1 insights, those sort of graphics you get that come up.
Yeah.
Say, hey, this person's more likely to do a pit stop than another, or we think this person could overtake this. We use machine learning and SageMaker to do that. But people are maybe not as aware of all the work behind the scenes to do the complex maths to actually, power some of these solutions.
Awesome. No, thank you so much for coming on the show. I really appreciate it coming in. Thank you.
Thank you.